Today I'm going to show you how to type your calculations for the percent yield of copper lab. So the first thing that we need to type is our balanced chemical reaction. We need to use subscripts for copper 2 chloride. So the way we can do that is highlight that number 2, go to Format, Text, and change it to a subscript. You can see over here that the shortcut is going to be Control, comma. To get out of the subscript, we're going to go back to Format, Text, and click on Subscript again. To type an arrow, we're going to do dash, dash, greater than sign. When you hit the space bar, it's automatically going to be changed to an arrow. For aluminum chloride, again, I need a subscript, and I'm going to use the shortcut. So I'm going to press Control, comma, and it's going to change my cursor to a subscript. All right, the next calculation that we're going to do is our calculation for molar mass. When we do this, we want to show our work, and when we're showing our work, we also want to include units. So the molar mass of copper is 63.55 plus 2 times the molar mass of chlorine. And in this hydrate, I have 2 moles of water. So I'm going to multiply the molar mass of water by 2, giving me a total molar mass of 170.49 grams per mole. If we look up aluminum on the periodic table, it has a molar mass of 26.98 grams per mole. And if we look up copper on the periodic table, it has a molar mass of 63.55 grams per mole. All right, for theoretical yield, we are going to go to Insert, and about halfway down you're going to see Equation. Your equation toolbar will pop up here, and we want to go to Math Operations A over B. So I'm going to start with my first given, which was 0.20 grams aluminum. If you use the right arrow on your keyboard, it will drop your cursor to the denominator. If you press that right arrow one more time, it looks like it disappears, but it's still there. So now I can do times and include the rest of my calculation. I'm going to go back to Math Operations, A over B. If we're starting with grams, the first thing that we're going to do is divide by the molar mass. And based on our calculations above, we see that the molar mass of aluminum is 26.98 grams per mole. Again, arrow over on your keyboard and we can add our next step. We're going to go back to Math Operations, A over B. Since my given is aluminum, but I'm solving for the theoretical yield of copper, I'm going to need a mole ratio. So looking at my balanced reaction that we already typed up, we can produce 3 moles of copper from every 2 moles aluminum. Lastly, if we want the theoretical yield of copper, we want to solve for grams of copper. So our last step is going to be multiplying by the molar mass. Our scales can measure to 2 decimal places, so I see that my given has 2 significant figures. I'm going to round my answer to 2 significant figures, 0.71 grams of copper. All right, remember when we're doing theoretical yield, we have 2 givens, we need 2 calculations. So now we're going to do the exact same thing with our other reactant. I started with 3.50 grams copper 2 chloride. When you're in the equation function, you cannot go to Format, Text, and Subscript. It's not going to make it a subscript. Control, comma will not make it a subscript. So the way that we can make subscripts in the equation function is by going back to Math Operations, and we want to go to X subscript A. I can type CU, CL, and then I'm going to press the right arrow on my keyboard, and it's going to drop your cursor down so we can now type our subscript. My suggestion is to copy-paste this, that way we don't have to retype it. So let's copy that. All right. Again, if we are starting with grams, our first step is going to be dividing by our molar mass. For every 1 mole of our copper 2 chloride, my molar mass was 170.49 grams per mole. Again, we're solving for copper, so we're going to need a mole ratio. Based on my balanced reaction, I can produce 3 moles of copper for every 3 moles of copper 2 chloride. And then lastly, we're going to multiply by the molar mass to solve for grams. My given has 3 significant figures, so I'm going to round my answer to 3 significant figures. The last calculation that we want to do is for percent yield. So the first thing we want to do is go back to math operations, and first we're going to click on the parentheses. Next, we're going to go back to math operations and do A over B. The first thing that we want to do is type out the equation in words. So the equation for percent yield is we're going to take the actual yield divided by the theoretical yield and then multiply by 100. I'm going to copy paste this. The second step is we want to plug in values with units. So let's say my lab group actually recovered 0.63 grams of copper. Based on the calculations that we did above, we can see that the theoretical yield is going to be 0.71 grams. And then again, we want to multiply by 100 to get it in percent form. My final answer would be 89%.